Alright, boys and girls, this is only my second video, but hopefully this will help you catch up on notes when you don't have them. So we're going to use systems of equations to solve word problems, to solve those systems by graphing. So we have Julio bought tables and chairs for his restaurant. He bought 16 total items and spent $1,800, $1,800. Each table cost $150 and each chair cost $50. Let X represent the number of tables and Y represent the number of chairs. How many tables and chairs did he buy? So this is what we really are trying to figure out. How many tables and chairs did he buy? So step one is to define your variables. Hey, they actually did it for us. But if they don't, then we still have to do it. So in this case, it told us X is going to represent the number of tables. So let X be the number of tables. And let Y represent the number of chairs. So let Y be the numbers of chairs. The number of chairs. And then now we're going to use those variables to write out our two equations. Well, the first thing that it tells us that he bought 16 total items. So if we take the number of tables that he bought and we add to it the number of chairs that he bought, we should get a total of 16, right? So that was a pretty simple equation to write. X plus Y equals 16. The number of tables he bought plus the number of chairs equals 16. The other one's a little trickier. What we're going to look at is each table cost $150. So if we multiply the cost of 150 times the number of tables he bought, we should know that part of how much he paid just for the tables, right? So we can write that out. And then same thing with the chairs. Each chair costs $50. We can multiply 50 times Y, the number of chairs he bought, to figure out how much he paid for those. And then the total of how much everything he paid is $1,800. So let's use that. He paid $150 times the number of tables. So that's 150x. And we add to that, chairs are $50, 50 times Y, the number of chairs. And then that's going to give us our total of $1,800. All right, let's use those two equations. First, let's go ahead and label our axes a little bit. I'll give you a minute to think about that. What should this axis be and what should that axis be? Right, it specifically told us that X is going to be the number of tables and that Y is going to be the number of chairs. So now all that we have to do is figure out what numbers to label here. And let's actually wait on that. Let's go ahead and solve our equations a little bit, or rearrange them maybe so we can see. Well, so there's our first equation, x plus y equals 16. I'm going to subtract x from both sides, and I'll end up with y. So I subtract x from both sides, I end up with y equals negative x plus 16. That's in slope-intercept form. That'll be really easy to graph. How about my next equation that I got from the previous part of this page? 150x plus 50y equals 1,800. I need to get my y by itself, so I'm going to subtract 150x from both sides. I'll end up with 50y equals negative 150x plus 1,800. Still need to get my y by itself, so I'm going to divide by 50, divide each term by 50. And I will end up with y equals negative 3x plus 36. All right. Well, let's see. So we're going to have up to 36 of something, because here's my y-intercept. But you know what? The bigger I make this, the harder it's going to be to see. So I'm actually going to trust, this is a gamble, I'm going to trust that he's not going to buy 36 chairs and no tables, because that would just be silly, right? So I'm going to go ahead and number by twos, and that's going to get me up to 30 on each axis. And I think that's going to be far enough. So I'm going to number by twos, 2, 4, 6, 8, 10, skip 1, 14, because I'm still going by twos, right? I'm just not writing every number. And now I can plot my first equation. My intercept is 16, and my slope is negative 1. So I'm going to plot my line. Oop. And now this other one, I've got an intercept of 36, but that's not going to fit on my graph, right? I already decided that. So I'm going to create a table. See, there's x and there's y. If I plug in 0 for x, I already know I'm going to get 36 for y. So what if I plug in 2 for x? Well, 2 times negative 3 gives me negative 6 plus 36. That gives me 30. Hey, and that'll fit on my graph. Cool. Let's get 2 more numbers. How about if he bought 6 tables. If I plug in 6, negative 3 times 6 is negative 18, plus 36 gives me 18. And if you need to use a piece of scratch paper, by all means use a piece of scratch paper. I'm just doing it in my head. But scratch paper is always something good. So let's see, how about I plug in one more? How about I plug in 10? Negative 3 times 10 gives me negative 30 plus 36. That gives me an output of 6. All right, now this one didn't fit on my graph, but these 3 will fit on my graph. So I'm going to plot those points, and I'm going to draw my line. Now it looks to me like I have a solution point of 10, 6. So I think he bought 10 tables and 6 chairs. How am I going to know for sure? That's right, I'm going to check my solution. So if I plug in 10 and 6 to my first equation, where all it says is he bought 16 total items, sure enough, that equals 16. But how about looking at the prices? If he paid $150 per table, and he paid $50 per chair, does it come up to $1,800? So I'm going to plug those values in, plug 10 in for x, and 6 in for y, and check, does that equal 1,800? Do the math, and sure enough, that does equal 1,800. So my actual answer is that he bought 10 tables and 6 chairs. And there's my answer, even though I ran out of room. Alright, so let's move on to what's going to be your classwork and your homework. Let's do one together, and then the next one you will do for homework, maybe more depending on how it goes. This is just a reference. This is just the notes that we already saw, but you can use this in your homework if you want to. Alright, example 1. Alyssa and Michaela are both dog sitters. Alyssa charges $2 per day plus $3 registration fee. That is cheap. Michaela charges a flat fee of $3 per day. After how many days do Alyssa and Michaela earn the same amount for dog sitting? Write a system of equations using y to represent the total amount earned in dollars for x days of dog sitting. Yay, it gave that to us. Then solve by graphing. Be sure to check your solution in both equations. Alright, so even though it told us, I'm going to go ahead and declare my variables. Let x be the amount that they earned. Let y be the amount that they earned, and x be the amount of days that they worked. So my first equation is going to be for Alyssa. She charged $2 per day plus a $3 registration fee. So that's going to be y equals 2x plus 3. So that's $2 per x days plus 3 is going to give me y, the amount of money that she earned. Let's write Michaela's. Well, Michaela is just going to be y equals 3x. So the amount that she earns equals 3 times the number of days. I have to make sure to label my axes. X is the number of days. Y is the amount that they earned. And now both of these are in slope-intercept form, so they're really easy to graph. There's my intercept. Use my slope to draw my line. There's my other intercept. Use my slope to draw my line. I think I have a solution of at 3 days they both earn $9. Let's plug those in to be sure. If I plug in 3 for x and 9 for y, do I get a true statement? Sure enough, I do. How about for Michaela? If I plug 9 in for y and 3 in for x, do I get a true statement? Yes, I do. So now all I have to do is write my answer as a complete sentence, and I am done. They earned the same amount for dog sitting at 3 days.